Hi everybody, welcome to lecture number 4 of surface areas and volumes. In this lecture, we will be discussing on conversion of one solid into another. So what does this conversion mean actually? Let's say we have a lot of wax with us and it is inside a cylindrical container. Okay, it's inside a cylindrical container here. And from this cylindrical container, it's in the molten form. Let's say I'm heating it. Okay, I'm heating it using a burner and I'm heating this candle. This wax. So this is completely filled with molten wax now. And I'm just inverting it and pouring into another box. So for illustration, I'll just draw a cylinder that, from which I'm pouring out this wax. So just a minute. Okay, so we have a cylinder and a box. Okay, so we have a cylinder as well as a box. In this cylinder, what did I tell you? There was molten wax inside. Okay, the total volume of this cylinder was filled with molten wax. So I'm now tilting this cylinder. So what happens? Whatever molten candle was inside, molten wax was inside, it will now start to flow into this one. Right now, it will start to flow. Whatever candle was inside, I'm just drawing whatever wax, okay, is now flowing into this cuboid, this box. So this starts to fill. This starts to fill like this, right now. So from this cylinder, I'm tilting this wax to fill up this cuboid. So tell me if the volume of this cylinder will be equal to volume of this cuboid, because this is completely filled. Okay, I'm tilting this whole vessel and the whole wax from this cylinder will fill this cuboid. So can I say volume of cylinder, that is this cylinder, maybe it had a height h and some radius r, some diameter r, and this had a length, and this had some breadth. This had breadth and it had some height. Okay, so can I say volume of this cylinder is now equal to volume of box, that's a cuboid? Can I say like that? It's possible, no? So you get volume of cylinder is pi r square h is equal to L into B into H. This is how I have converted this shape into this one. Okay, the volume of this particular shape will be equal to this particular shape because I'm making something out of this. This is the whole concept that we are going to discuss in this particular section, that is conversion of solid from one shape to another. So now that the concept is clear, let's move on to the question. Okay, so here is question number 1. So let's start with that. A metallic sphere of radius 4.2 centimeter is melted and recast into the shape of a cylinder of radius 6 centimeter. Find the height of the cylinder. So what is given? There was a sphere. It is melted and recast into the shape of a cylinder. Okay, just like before. You have to find the height of the cylinder. So what are the shapes we have? You don't actually need to draw figures for this, but still for you to understand, I'm drawing a sphere as well as a cylinder. Okay, so here's a sphere. Okay, so we have a sphere and it is melted to form a cylinder. Okay, so what are the things given? Of radius 4.2, the radius of the sphere is 4.2. Okay, and that of cylinder, recast into a cylinder of radius 6 centimeter. Here the radius is 6 centimeter. You have to find the height of the cylinder. We don't know what the height is. Okay, so you have to just find out. So let's start by writing all the entities here. What do we have? We have a sphere of radius 4.2 centimeter, or you can write it as 42 by 10. Then we have a cylinder. What's the radius given? Radius given as 6 centimeter, and height is h. That's what we have to find out. What is the volume equation for a sphere? It is 4 by 3 pi r cube. Here the volume is pi r square h. So here both r's are different, so let's put this as r dash. Okay. Now solve. Volume of cylinder, volume of sphere equal to volume of cylinder, right? Yeah. So volume of sphere is 4 by 3 pi into r cube, that is 42 by 10, 42 by 10 into 42 by 10 equal to volume of cylinder, that is pi into r square, that is 6 into 6 into h. Now I have to find out the value for h. I think that will be easy. Pi cancels, 6 42 cancels, 6 sevens are 42. Then you have to multiply all these things and get the answer. Okay, so let's see. You have h is equal to, now you have h is equal to, h is left here, no? H is equal to 4 into 7 into 7 into 42, 4 into 7 into 7 into 42 whole divided by 3 into 10 into 10 into 10. What else can be done? 3 14. Okay, so what do we get? Multiply all this is, what do we get now? 2744 divided by 1000. The answer will be, jumps 3 times, 2.744, or simply for keeping it in 2 decimal places, you get the answer as h is equal to 2.74 centimeter. Now that is the answer for the first question. So similar questions will be there. We'll discuss more difficult questions. Okay, so let's go to the next one. Here is question number 2. What is it telling you? Metallic spheres of radius 6, 8 and 10 centimeters. So there are 3 spheres. They are melted to form a single solid sphere. Find the radius of the resulting sphere. Okay, so this is how the figure is. Now let us mark the dimensions given. Metallic spheres of radius 6 centimeter. So this is of radius 6 centimeter. Okay, and 8 centimeter. This is of 8 centimeter. And then we have a sphere of 10 centimeter. Okay, very good. Now this sphere is the final sphere. We are melting all these things and forming this one. No? So let the radius of this sphere be r. I don't know. Okay. Now let's mark what are the things that is given. So let's look at solution. Let's say sphere 1, S1. What is the radius? R1 is 6 centimeter. S2, sphere 2, R2 is how much? 8 centimeter. Sphere 3, R3 is 10 centimeter. Then we have the resultant sphere. Let's say SR. Let the radius be R itself. Okay. Now can I say that the volume of this plus this is equal to volume of this one? I can do that, no? So let's write volume of the first one is 4 by 3, or I will write the formulas, the statement first, that is volume of S1 plus volume of sphere 2 plus volume of sphere 3 equal to volume of resultant sphere. Can I say that? Yes, I can. Now substitute. Now write the formulas for everything. You get 4 by 3 pi r1 cube, 4 by 3 pi r2 cube, 4 by 3 pi r3 cube equal to 4 by 3 pi r cube. This r I don't know, I have to find out. So don't think of solving all these terms individually, okay? We can go for a more easier method. Take 4 pi by 3 common. So you'll get r1 cube plus r2 cube plus r3 cube, which is equal to, again, 4 by 3 pi r cube. Okay, this is the smartest way of doing. Don't go for individually finding answers. You will make some error. You will make an error calculating this one, then an error calculating this one, then an error calculating this one. You will add all the errors, and finally you have a bigger error. So why do we want to go for that? So 4 pi by 3 goes to the other side. This and this cancels. Pi cancels. So you have r1 cube, r2 cube plus r3 cube is equal to r cube. Alright, that is 6 cube, that is 36 into 6, 216 plus 8 8s are 64, 512 plus 1000 is equal to r cube. So when you calculate everything, we get 8 to 7. Okay, so you get r cube is equal to 8 to 7, 1728. Okay, now you have to find out the cube root of 1728. How to find out cube root? You can find r is equal to cube root of 1728. How to find out 1728? Let's do the prime factorization method. 2 8s are 16, 6 4, 2 4 3 2, 2 2 1 6, 8 54, 27, 3 9. Yeah, so this is 3 cube. So you'll combine 3 numbers at a time, that is 2 into 2 into 3, that is 4 3s are 12 centimeters. So radius of the resulting sphere, the sphere that was here, will be 12 centimeter. Understood? What was the question? There were 3 spheres. We melted it to form a bigger sphere. We are supposed to find out the radius of that sphere, and we did that. The volume of all these spheres, small spheres, will be equal to volume of bigger sphere. Solving, you got the answer as 12 centimeter. Okay, so please note things down, and we will go to the next one then. Okay, so let's discuss question number 3 here. It says a 20-meter deep well with diameter 7 meter is dug, and the earth from digging is evenly spread to form a platform 22 meter by 14 meter. Find the height of the platform. When you say platform, what is the shape? It is given 22 meter by 14 meter, something by something, length by another dimension. What is it usually? It is telling you that the base is rectangle. So when you give it a height, it's a cuboid. No, the platform is in the shape of a cuboid. So let's see, there is a cylinder first. Okay, so okay, so here is a 20 meter deep well. 20 meter deep well. So I'm just going to mark the height here. It's a 20 meter deep well, and it's dug, and the earth is diameter 7 meter. Okay, diameter is given as 7 meter. Okay, it is dug and evenly spread out to form a platform 22 meter by 14 meter. So this length is given as 22 meter, and this is 14 meter, and the height of the platform we have to find out. So let this be the height. That is the height of the platform. So what is it? Just like before, the volume of this well is equal to volume of this platform. So we have two things here. We have a cylinder, and we have a cuboid. That's a platform. Okay, what are the things given? What are the dimensions given? H is equal to 20 meter. Agreed. Radius r equal to 7 by 2 meter. Because the diameter is given as 7, radius will be 7 by 2. For cuboid, length is 22 meter, breadth is 14 meter, height we have to find out. So what is the volume? Here volume is pi r square h, and here volume is equal to LBH. So when you equate both, you have pi r square h is equal to L into B into H. Oh, here H is different, so let this be H dash. This will be H dash. H dash. Okay. Now substitute. What do you get? You get 22 by 7 into r square is 7 by 2 into 7 by 2 into height is 20. Here length is 22 into 14 into height, I don't know. Okay, so what are the things that you can cancel? You can cancel 22 here. You can cancel 7 and this will be 2. this 2, 20 goes, it will be 10, 7, 7 goes, so this is 10 by 4. 10 by 4 is equal to h. What is 10 by 4? It is 2.5 meter. So the platform is very, very huge. Okay, it's a 2.5 meter tall platform. Right, so with that, the question is over. Let's go to question number 4. So here is question number 4. This is a little bit of, tricky question because you have to understand the figure carefully. It says, they're building an embankment around a well. Let's see how that turns out to be. A well of diameter 3 meter is dug 14 meter deep. So what is the shape of a well? It is in the shape of a cylinder. Okay, that's confirmed. The earth taken out of it has been spread evenly all around it in the shape of a circular ring of width 4 meter to form an embankment. Find the height of the embankment. That's the question. So do you get the idea of an embankment? It looks like, let's say, it looks like, let's say this is a well. Okay, so let there be things like this. Okay, this is a well. Okay, I think everybody has seen an embankment like this that is built around a well. Okay, usually this is what is called an embankment, and this is where the well lies. Right, so there is a well inside of this. There is a well and there is an embankment. Understood? So they are saying that this width of the embankment is given. Then what will be the width of the inner ring? What will be the width of the inner circle? That will be same as the width of the well, no? See? It's the same well. And the radius of this one, by width I meant to say the radius of this one. The radius of the embankment, inner ring will be same as the radius of the well. And the radius of outer ring will be this radius plus this width. Okay, so this is practically what it looks like. I'll just draw a figure to explain things properly to you. So let's draw a well and the embankment. Okay, so this is how the final figure looks like. You see, this is a well. This portion here, this is the well. Okay, is the height of the well given? How much is the height? 14 meter. Okay, this is 14 meter, and the diameter of this well is also given. So this is 3 meter. Okay, so this will be 3 meter throughout. Okay, here also it is going to be 3 meter, no? From the center, let's say I'll just rub out unwanted lines. Okay, so this is 3 meter. So this will be the radius. This much. How much will this much be? This will be 3 by 2. And what is the width given? What is the width? In the shape of a circular ring of width 4 meter. Okay, this width itself is 4 meter. This is 4 meter. Okay, so there are two circles. There's one circle inside and there's another circle out. One circle inside and another circle outside. So the radius of this circle is 3 by 2. What will be the radius of the second one? It will be 3 by 2 plus 4, no? From the center to the outermost ring, it will be 3 by 2 plus 4, that will be 11 by 2 meter. Getting my point? See, the inner radius is given as 3 by 2 and the width of this is 4. So what will be the total radius? It will be 11 by 2 meter. Okay, so now tell me, there is a ring, this is a cylinder, no? This is a bigger cylinder and there's an inner cylinder. So let's say there's a cylinder like this. This is a cylinder like this. Okay. If I know the volume of this cylinder, and there is an inner cylinder that is cut out like this. Let's say this is cut out. There is a cylindrical hole inside. Okay, this is in the form of a bigger cylinder, and from inside there is another cylinder that is removed. See, bigger cylinder, inside there is another cylinder. So can I say the volume of this one will be outer cylinder volume minus the volume of inner cylinder? Can I say that? See, this is the whole cylinder. This is the whole cylinder. From the inside, I have to remove this much. That much cylinder is removed. Okay. So the volume of the ring, that is all. I'm only worried about this portion. Only worried about this portion. The inner portion is removed. The inner portion is removed. So I have to find out the volume of bigger cylinder minus the volume of inner cylinder. Okay. So let's calculate the volume of, we have two cylinders here. One is in the bottom and the other is on the top. So I'm going to write embankment. Okay. Outer radius is R1 is how much? 11 by 2 meter. Inner radius R2 is how much? 3 by 2 meter. Okay. Volume will be how much? Volume of outer cylinder minus volume of inner cylinder. Is that correct? That will be 1 by 3 pi R1 square h minus 1 by 3 pi R2 square h. The height is same for both the cylinders. See, the height that is same for both the cylinders. The well is only up to this much, this portion. Okay. So what can I take out? Can I take 1 by 3 pi h as common? Then I will get R1 square minus R2 square. Easy. So this is the volume of this embankment. Now I have the well. I have the well. What is the radius of the well? Radius will be inner, radius will be inner circle, no? That will be 3 by 2, again 3 by 2 meter, and the height is 14 meter. So the volume will be, once a minute, it's not a cone, then why did I take 1 by 3? Why did I take 1 by 3 minute? So no 1 by 3 anywhere. It's not a cone, it's a cylinder. I'm really sorry. It's pi h into pi R1 square h minus pi R2 square h. Here also the volume will be pi R square R1 or 2, R2 square h. Okay. Now this volume is equal to this volume. Now equate. Let's say this is volume V1 and this is volume 2, V2. So V1 is equal to V2. So I get pi h into R1 square minus R2 square is equal to, this is h dash, h is different, pi into h dash into R2 square. Okay. So what all things cancels? I can cancel pi from both sides. Then I get h is equal to h dash into R2 square whole divided by R1 square minus R2 square. R1 square minus R2 square. How much is h dash? That is 14 into R2. 3 by 2 into 3 by 2, that is 9 by 4 whole divided by R1 square is 121 by 4 minus 9 by 4. So this will be 14 into 9 by 4 into 121 minus 9 is 112. Okay, so 112 by 4. Okay, this 4 cancels. Then how can we cancel? This will become 7, this will become 56. Okay, this is 7, this is 8. You get it as 9 by 8. That is 8 plus 1 by 8, 1 by 8 is 0.125. You get the answer is 1.125 meter. Got it? I hope you understood the concept of a ring, that is the outer cylinder minus the inner cylinder, which is same as the earth taken out from this well. So finally you get the answer, that is h, that is this height is 1.125 meter. H is equal to 1.125 meter. All right. So with that, the question is finished. We will go to question number 5 in our next video. Thank you so much for watching.